Hello class, we're going to go ahead and do section 5.2, which is solving quadratic equations by graphing. So you're going to use your ideas from yesterday, being able to graph, and then we're also going to find the solutions. So we need to talk about where the solutions are on a graph of a quadratic. Okay. Just to refresh your memory, a quadratic equation is ax squared plus bx plus c. In order to solve it, there has to be an equal sign in order to solve something. So you solve it when you set it equal to 0. Okay, so if you have a number on the other side, you need to get it set equal to 0, then you can go ahead and solve. The way that we can solve is we can have 1, 2, or no solutions with a quadratic. Okay, so one solution. The solution is wherever it hits the x-axis. So remember, this is your x-axis. So it's wherever it hits the x-axis. Notice it only hits the x-axis once. So there's only one solution. Here's my x-axis. Hits it twice, so there are 2 real solutions. And here's my x-axis. My quadratic is not touching my x-axis, and it will not touch my x-axis. So there is no real solution here. Another word that I might use is that the solutions of a quadratic equation are also called the roots of an equation. Okay. And to find by graphing, you can find the zeros, which are the x-intercepts of the graph. Okay, so if I ask for the zeros or the roots, it's the same thing as solving the quadratic. So find the following and then graph. Then state where the zeros are located. So 1 says x squared plus 6x plus 8 equals 0. So we have it already set equal to 0. So we need to graph it, and then we're going to find the solutions. Well, we know from yesterday that our y-intercept is our c value. So it's, remember, the order of pairs 0, c. So in this case, 0, 8. Then my vertex I find by opposite of b over 2a. So my b is 6. So negative 6 over 2 times 1. So I have negative 6 over 2, which is negative 3. So x equals negative 3 is my axis of symmetry. And my vertex then, remember from yesterday, to find my vertex, I plug in my axis of symmetry into my equation. So to find the y value. So y will equal negative 3, all of that squared, plus 6 times negative 3, plus 8. So this gives me positive 9, because negative 3 times negative 3 is positive 9. 6 times negative 3 is negative 18, plus 8. And remember, I add from left to right, so I get negative 9 plus 8, which gives me negative 1. Okay, so my vertex then is the ordered pair, negative 3, negative 1. So we need to go ahead in order to graph to find our zeros. So my axis of symmetry is x equals negative 3, so remember it's a vertical. And then my y-intercept is 0, 8. So this one won't fit perfectly on here, but here's 0, 8. And then also if I have 0, 8, I'm going to have negative 6, 8, my symmetric. And then my vertex, negative 3, negative 1. And I go ahead and I graph. Okay, and when it's graphing, it's not always absolutely perfect, but my zeros, so I look on my axis symmetry. Sorry, I look on my x-axis for my zeros, and if I look here, it's when x is equal to negative 2 and x is equal to negative 4. So those would be my zeros or my solutions. So in this case, this is when I have 2 solutions. Go ahead and look at example 2. If I look at example 2, this is not in standard form. And by standard form, I mean I have everything on one side, and then I have it highest exponent to the lowest exponent. So I'm just going to reorganize. I'm going to put this first. So I have negative x squared plus 8x. Now I'm going to move 16 to the left-hand side. So I would have to subtract 16. Now it is in standard form. I would like for you to go ahead using the standard form to find the y, the intercept, the vertex, the axis of symmetry, and then graph it, and then find the zeros. So go ahead, pause the video now, and do that. All All right, for this problem, you should find that your y-intercept is 0, -16, your vertex is 4, 0, and your axis of symmetry is x equals 4. When you go ahead and graph all of those things, and you look at your y-intercept, I know it doesn't fit on your graph, but you know that it's going to be heading downward. So if I look at this, I'm only going to hit my x-axis at one point, and then that is where x is equal to 4. So my solution is when x is equal to 4. So in this case, this is an example of only one solution. Okay, let's go ahead and flip onto the back side of our notes and look at number 3. Same thing, we want to find the following and then graph it and then find the zeros. So I want you to go ahead and find the y-intercept, the vertex, and the axis of symmetry and graph it, and then we'll come back together to find the zeros. So go ahead and pause the video and do that. Okay, if you go ahead and do everything that we did on the last video notes, you should have got your y-intercept was 0, -1. Your vertex was 2, 3, and your axis of symmetry was x equals 2. Then you go ahead and you graph. This time what you notice is if you look at your x-axis, so remember that here is your x-axis. My solutions are where it hits, so here and here. These are not nice integer solutions. So in this case, we just estimate or we tell them where it's in between. So we say it's between, well, the first one's going to be between 0 and 1. And my other solution is in between 3 and 4. It's in between 3 and 4. Maybe, there we go, 3 and 4. So there's your solution for number 3. So remember, the only thing that we're really doing new today is we're saying where the zeros are. And remember, the zeros are your roots, and they are located on your x-axis. So wherever the quadratic or the parabola hits the x-axis, those are your zeros. Let's go ahead and look at a few word problems. In 1999, Adrian Nicholas broke the world record for the longest human flight. He flew 10 miles from a drop point in 4 minutes and 55 seconds using an aerodynamic suit. Using the information from the diagram and ignoring air resistance, how long would it have been in free fall had he not used his suit? Use the formula h of t equals -16t squared plus h sub 0, where the time t is in seconds and the initial height h sub o is in feet. Well, h sub o is the height, initial height in feet. Well, our initial height that he's starting from, if we look at our diagram, so we have -16t squared plus our initial height that he starts from is 35,000. So plus 35,000. Okay. And we are looking at when he free falls, only when he free falls. So if I look at the diagram, he's free falling from 35,000 feet until he gets to 500 feet. Then he opens his parachute. So if I take 3,500 minus 500, he's really free falling for 34,500. Just something to take note of. Okay. So my h of t, well, we want to use this equation until he reaches a height of 500 feet. So I need to go ahead and solve this problem. So the first thing that I would do is subtract 500 from both sides. So I have 0 is equal to -16t squared plus 34,500. Now one thing that I notice is that there's no b value. I don't have a number with just a t. So I can actually solve this algebraically. I don't need to graph it. So I would subtract 34,500 to the other side. So I have -34,500 is equal to -16t squared. I would then divide by -16. Okay, when I go ahead and divide by -16, I get 2,156.25 is equal to t squared. And then in order to get t by itself, I would take the square root on both sides. Okay, so you should get t is 46.435. Okay, and what this would be is we would label it. This is in time. So he free falls for 46.435 seconds. There is my solution. Then it says, how in the world will we graph this? Well, the nice thing is we have technology and we can go ahead and graph this on our graphing calculator. I'm going to walk through how to do this on the TI-84 quickly. And so just to get an idea of how you could use it. So what you do on your TI-84 is you go to y equals, okay, and you put in the equation that we have. Not just any equation, you need to put in this equation. Mary in red. The one where you have 0 equals in standard form. So I have negative 16, and there is, let's see this. There is no t for in this example, but you can use x. Okay, x squared. Maybe x squared. There we go. Plus 34,500. Sorry, this is kind of picky. There we go. 34,500. And we're going to go ahead and graph it. But what we probably want to do is look at our window settings first. We know that we have a Y-intercept of 34,500. So I would maybe recommend changing your window. So you go to your window settings. And my X-min, so that's your left and your right. Well, we know that the answer is 46.535. So I'm going to go ahead and just say, well, I don't really have 0 seconds. So I'm going to go from, negative seconds. So I'm going to go from 0 up to like 50 for my X. And then my Y is how high it is. So we don't really need to do negatives, but I'll leave it at negative 10. And then the height, well, we're starting from 35,000. So I'm just going to put 35,000 as my height. And then I go ahead and hit graph. Okay. And here is the parabola showing. Okay, it's only a part of it. Then if I want to figure out what this ordered pair is right here, because that's where he's reaching the ground, you would go second calc. Okay, and we want to find the 0. So I would hit 2. Okay, then it says left bound. Notice how right here it's flashing. Okay, so that is left bound because it is to the left of the point we're trying to find. Here's the point we're trying to find. So you need to be to the left. So you hit enter. And then you go ahead and notice how it's showing me to move to the right with this little triangle here. Just like that. So I move to the right using my buttons. And I have to make sure I get to the right of the ordered pair we're trying to find. So notice I'm still to the left. Okay, now I can't see it anymore, and my Y is also negative, so I know I'm to the right, so I hit enter. And then if you notice it says guess, it wants you to try and get as close to the point as you possibly can and guess, but you don't have to do that, so just hit enter again. And look it's when X is 46.435439. Okay, so that is our seconds, and it was when Y was 0 or our height was 0. Okay, so there's how you can do that on your calculator and make life easier. We are going to go ahead and stop with the notes for today. If you would like to attempt number 5, it's very similar to number 4. Go right ahead, and then we'll go ahead and finish number 5 in class tomorrow. Have a good night, and I will see you tomorrow.